A couple of things we're talking about shared memory, and it seems to be one of the threads running through the show, large shared memory systems, and at the extreme end of that, we've got our pals from SGI, we got Geoff, how do you pronounce your last name?
Jeffrey Noer.
Geoff Noer, okay. Get that right. Say hi to Mom if you want to say hi to Mom if she's reading my blog. Doubt it. I really doubt that. So what are we looking at here? This is finally UltraViolet, right?
Absolutely. So imagine an open platform, x86 based, runs unmodified Linux, either from SUSE or Red Hat, no changes, run your standard x86 applications, everything just works, but you can scale to 2048 cores.
In a single operating system.
Single operating system image, 16 terabytes of memory.
It's a lot of memory. That's a lot of cores. That's incredible. Now, we were talking a minute earlier about what customers are doing with it, and it was kind of surprising to me that they're running, you were saying, what were you telling me? Surprise the audience as well.
So there are a couple of different usage purposes of a system like this.
Yeah.
One is actually, this isn't just, this is appealing to the world's largest supercomputing centers.
Yeah.
You can use it as an analysis supernode
for applications and workloads that aren't easily parallelizable and parallelized, right, that need a large shared memory space. Sure, makes sense.
Exactly.
Natural.
So you may have hundreds of teraflops available on a large cluster, but you may have those algorithms that need shared memory that would be running on a system like this.
Gotcha.
We also have the mid-market, and we have a 3U rack mount chassis that supports 2 of the blades.
Okay.
It allows you to scale 4 sockets at a time.
Okay.
So if you have somebody who's using an 8-socket SMP server right now, running something like ANSYS Fluent, and they want to step up to something a little larger than what's available commonly on the market, they could very easily expand to a 16-socket or a 32-socket system and still benefit from all the advantages with NumaLink 5,
sure,
MPI offload, all the other.
But weren't you saying that a lot of the interest you're getting is for people just running standard MSI type applications because it's going to run a lot faster?
Right. Basically, any MPI load is going to be greatly accelerated with this architecture. Less than 1 microsecond, at least for the raw connection between hops.
Yeah.
And it's only slightly over 1 microsecond, including all of the MPI transaction overhead. So very, very low latency. That means dramatically faster results than using a software-based SMP solution, for example, or trying to use a cluster.
Okay. Good stuff. Well, thanks a lot. And again, 16 terabyte single system image?
Absolutely.
You guys have brought that up.
And we can actually scale beyond that, all the way up to 32,000 sockets, hundreds of thousands of cores, and still have a global address space. It's just no longer coherent.
Yeah.
And then you run into multiple OS images. But 256 sockets, 2048 cores with one OS image.
That's fair
enough. Else comes close.
That's not bad. Great. Thanks a lot. Appreciate it.
Okay. Thank you.